Hello guys, welcome to my channel, and in this tutorial we'll learn about basics of computer vision using OpenCV in Python. So let's get started. And now let's try to rotate the image. And so before directly getting into that, you should know actually what all are rotate an image. So to rotate an image, we need to know the center and the angle to be rotated. That's quite important, right? Without knowing the angle and without knowing where the center is, it's really difficult to rotate the image, because you need to have a standard, right? Like if I say go, then that's that doesn't make any sense. I should give you the direction: go left, go straight, go right. So in a similar way, rotate itself doesn't make any sense. So if you have to mention the criteria, so this is the center and I want it to rotate by this much angle. So here to find the center, it's very easy, because image.shape will give you the height and width. So I'm considering the first two elements. So like, see, image.shape will give you these three values, right? 720, 1280, 3. So this is called slicing. So by slicing this, you'll be getting only these two values, so 720 1280. So your h will be 720 and w will be 1280. Now center is 1280 divided by 2 and 720 divided by 2. That's quite fair, right? Yeah, obviously center will be w by 2 and h by 2. So we calculated the center, and now I'm defining a matrix equals to cv2 dot get rotation matrix 2d, and here I'm giving one of the parameter as a center, and this is the angle, the angle by which it should rotate. So if you could look, I'll explain what why it is a 2 by 3 matrix and all. Let's then what we did is rotated equals to cv2 dot warp affine, and here we gave one of the parameters as our image, and the other parameter is the matrix that we have mentioned here. So here it would be the 2 by 3 matrix, and the other parameter as your width and height. Now I'm going to print the matrix dot shape as well as the show the image, rotated image. So let's just run this, and also this this cv2 dot warp affine, this will get you the applied rotation to the output of your previous transformation. Look, this is the transformation we did, and it'll find the rotation to the output of the of this matrix. Cool. Let's just run this and see. You can clearly observe that the image has been rotated to 45 degrees with respect to the horizontal. Okay, let's see the shape, and it is, yeah, as mentioned here, it's a 2 by 2 cross 3 matrix. And yeah, so it says affine, right? So what affine transformation means is, affine transformation represents a relation between two images. Consider you have two images, so the relation consider you have two images, so the relation between them is defined by the affine transformation. Like basically the transformation can be expressed in the form of matrix multiplication, which is also you could consider it as a linear transformation, followed by a vector addition, which you can consider as a translation. So like if you have a, like if you are really good at vectors, then you should know these these terms, right? Linear transformation, translation and all. So like what we actually do is we perform the affine transformations whenever we want rotations, or whenever we want to translate the image. Rotations and translations. So rotation is considered as a linear transformation, whereas translation as vector addition. And also you can also perform the scale operations. That means that is also considered as a linear transformation. And the usual way to represent an affine transformation is by using a 2 by 3 matrix. So that is the reason why you got this matrix as a 2 by 3 matrix. So let me show you clearly. For clear understanding, you can go to OpenCV documentation. So here you can see this is the A and this is B, and this is our matrix M. So M is considered as this. So if you could see the shape of the M, then it is 2 cross 3, right? And considering what we want to transform a 2D vector X, here the X is a 2D vector. By using A and B, you can, this is how you can transform. So you can go through the documentation for further understanding. I'll provide the link in the description. And yeah, coming back, now we'll see drawing on image. So okay, you have the image and you want to draw something on the image. So let's start with basic lines. Let me create a copy of my image and let me store it as a test, because we are testing on our image. We are randomly testing different lines, shapes and all. So let me just create a copy of my image. So image.copy, and I'm storing it as test. Now cv2.line and test is the image, and these are the coordinates. So this is the starting coordinate, this is the ending coordinate, and this is the color of the line. Okay, so note that it is in BGR format. So here B is 255, G is 0, and R is 255. Right? All these channels have values from 0 to 255. If all are 255, it indicates white. If all are 0, it indicates black. And if first the first element is 255 and the rest all are 0, then it represents blue. And if this is 0 and this is 255, this is 0, then it represents green. And 0 0 255 indicates red. So similarly you can check giving different values, but note that the value should be between 0 and 255. So and the next one would be the thickness, right? So yeah, let me just run this, so that now it should appear, you should get now you should get a image with a line from 0 0 to 150 150, starting from this coordinate and indicate this coordinate. Let's see. Look, we have a line passing from 0 comma 0 would be this, and 150 comma 150 is this. So you have a line. Cool. And now let's try looking into rectangle, like drawing a rectangle. Again, cv2.rectangle, and the first one would be the image. Here it is the top left coordinate, and here it is the bottom right coordinate of a rectangle. And again, this is the color. So you could say this is a green colored rectangle, and this is the thickness. Okay, let me just again run it. Look, so here we have mentioned as 260 comma 10 as the top left coordinate. So that would be this 260 comma 10, and the bottom right coordinate is 460 comma 200. That indicates this is the 460 comma 200. Now let's see a circle. Let's draw a circle. Again, for circle, the first parameter would be the image, and next the center of the circle, and this is the radius of the circle, and again this is the color, and this is the thickness. Again, let's run this. Look, you have a circle, and if you want to enclose it, or you want to autofill it, then you can directly give -1 in place of thickness. So let's just run this. Look, now the circle is filled. So by giving -1 to the thickness, you can fill the circle. And if you want to draw some random polygon type or different one, or any random shape or random lines that are passing through different points, then you just need to define some points here. So here I'm defining few points, 1 2 3 4, and all are integers. And now cv2.polylines, I'm giving the image, and then I'm giving the coordinates, and then this true indicates should we connect the final and the starting dot. Here I'm giving true. If you want to if you want a closed figure, then give it true, or else just give it false. And again, this is the color, and this is the thickness. So let's just run this. Look, this is a random polygon of it's a random polygon of 4 sides, and yeah, that's how you can give a polygons. You can also give more than 4 lines by just increasing the coordinates here. So that is it for this tutorial, and I'll see you in the next one.